Hello and welcome back to our tutorial series about creating an animal AI. A fish in my case, but this will work for any kind of animal. At the end of the series I will adapt it to work with various animals, like deers and foxes. Last time we did the initial setup where we created the main blueprints that we will use during the series. We created the blackboard and the behavior tree, and also, we created our first task that selects a random point in the world and moves the animal to that point. In this episode, we will be creating a simple hunger system and make our animal search for food and eat using environmental queries. So stay tuned and let's get to it. In our behavior tree, let's add a cooldown decorator to our roam sequence. Now, the sequence is executed over and over again. Adding this will make the sequence execute once and then not execute for the duration we specify in the settings of the decorator. Set the cooldown time to 20 seconds. From the selector node, create another sequence node. Let's create a random chance decorator. This will be a simple decorator that will randomly return true or false based on a chance percent. Choose BT decorator underscore blueprint base from all classes. Name it BD underscore random chance and open it up. Here, we have to override the perform condition check AI. Right-click and search for random float in range. Create a variable of type float and name it percentage. Make it instance editable. From the return value pin, pull out and search for less equal. Connect the percentage variable to the second input pin of the less equal node, and the result pin to the return node on the return value pin. Set the max value to 1. This is all there is to this decorator. Compile and save. Now let's use it. Back in our behavior tree, add a random chance decorator to the sequence node and set the percentage to 0.5. This means 50% chances to execute the sequence. Let's add 2 play animation nodes to play randomly when the animal is not moving. We will decorate each node with our random chance decorator. This will increase the randomness of the selection. Here you can have multiple idle animations playing randomly for the animal. You can set the percentages to whatever you like. Here I'm setting them to 0.3 or 30% and 0.7 or 70%. The sum of them doesn't need to be 1. You can have both to 0.4, and that will mean that the animation will have 40% chances to play when the execution of the behavior tree reaches the node. From the main selector, add a wait node. This will be executed if all other branches fails to execute, mainly because of the cooldowns or because of the random chance decorator returning false. Set the wait time to 10 seconds with a deviation of 5 seconds. This means that when the node is hit, it could wait between 5 and 15 seconds. This is another way to add randomness to the animal behavior. Don't forget to select the animations to play. It took me a while to realize my mistake. Here I'm selecting 2 different animations that I would like the fish to perform while waiting. You can add as many animations you like to the node and configure them with a random chance to play. Save the behavior tree and test. We can see that the fish is playing the animation, and we can see the branch executing in our behavior tree. For testing purposes, I will increase the chances for the animations. You will have to try and test to find what works best for your case. I will also decrease the wait time and deviation so that I don't have to wait so much while creating the system. If you do the same, don't forget to change them back to your chosen values when everything is in place. Now we can see better the behavior tree executing as intended. And we can see that we made a mistake. The animations play in a sequence instead of selecting between them. We have to change the sequence node to a selector. Let's do that real quick. Now we can see the animations playing only once as intended. Create a new folder and call it AI. We will move everything except the animal blueprint inside. Now, let's create a simple hunger system for our fish and add the eating behavior to our behavior tree. Let's start by creating a food blueprint that will contain only a sphere mesh and a nutrition value. So, create an actor blueprint and call it BP_food. Inside, add a static mesh and name it food. In the static mesh field, search for sphere. You can select any static mesh you want your food to be for your animal. For example, if you have a rabbit as animal, you could select a carrot static mesh. The sphere is quite big, so I have to resize it to a more manageable size. Add an AI perception stimuli source component. Select auto register as source and add site to the register as source for senses array. Compile and save your blueprint. Back in our AI folder, create a new blueprint of type environment query from the artificial intelligence category. Name it EQS_site. Open the blueprint and, from the root node, select actors perceived by querier. In the allowed actor class, select our BP_food blueprint. In the senses to use, select the site sense. Save and close. Save and go back to the behavior tree. Right-click on the selector node and add a Run EUS service from the Add Service submenu. From the top right corner, select Blackboard and create a new variable of type object. Name it Food Actor. From the key type, base class, select your food blueprint. In my case is BP_food. Save and go back. In the Details section of our EUS, in the Blackboard key, select Food Actor. This will be the variable that the environment query will populate with the actor it finds that corresponds to the filters we added inside the query. In the EUS request, select our EUS task named EUS_site. In run mode, you can filter the selected actor returned by the query. We will use single best item, but you can use single random item from best 5% or 25% if you have more food sources available and you want the animal to select one of them randomly. In the interval field, you can set how often the service will run. In this case, the default value of 0.5 is good for us. You can also set a random deviation if you need it, but in this case it's not needed, so we will leave it at its default value of 0.1. Add a new decorator to the selector. This time we will choose a Blackboard decorator. This decorator ensures that the branch will execute only if the condition set in its configuration is met. In the Details panel, set the key query to is not set and the Blackboard key to Food Actor. This means that this branch will execute only if the Blackboard key Food Actor is not set. Also, set the value to Observer aborts to both. This will force the branch to abort any task is currently running if the value of the variable Food Actor changes. From the root, create a new node of type selector and connect it back to our idle sequence. From the selector node, create a new sequence node. Here we will create the eat sequence. Let's organize the nodes a bit so it's easier to read. Name the selector Investigate and Eat. Add our EQS service to the node and select EQS_site as query template in the Details panel. Also, set the update be beyond fail to false. We don't want to clear the Food Actor variable in the middle of the sequence. Add a Blackboard decorator and set the key query to is set and Blackboard key to Food Actor. This time, we want to execute this branch of the behavior tree only if the Food Actor variable is set. We don't need to abort it. Add a Rotate to face BB entry task from the selector. In the Details panel, set the Blackboard key to Food Actor. Add a Wait task to act as a buffer and set it to 1 second. This will make the animal appear curious about what he just saw. Add a move to task and set the blackboard key to food actor. Add another wait task and set it to 0.5 seconds. This will also act as a buffer and will give the actor time to settle at the end of the movement. Add a play animation task and set the animation to the one you want your animal perform during the eating action. Save your behavior tree. Let's add the food actor to our world. Pay attention to place the actor inside the nav mesh volume so the animal can reach it. Open up the AI controller blueprint. Delete the AI perception stimuli source. Search for AI perception component and add it to the blueprint. In the details panel, search for AI perception and in senses config add a new element. Set AI site config. The dominant sense will be, by default, the one configured at index 0, so you don't need to configure it unless you have more senses, and the one at index 0 is not the dominant sense for your character. In the sense config details, let's lower the sight radius to 300. This means 3 meters in Unreal units. Also, lower the lose sight radius to something a little bigger than the sight radius. I'll set it to 350 for now. I'll also set the peripheral vision half radius to 45 degrees. This means that the vision cone for my fish will be 90 degrees. Set the max age to 5. This will make that the animal will forget the food actor after 5 seconds starting from the moment the food actor left the vision cone of the animal. For the point of view backward offset, I'll set it to 20 and near clipping radius to 10. This will create the illusion that the animal has peripheral vision. You will have to play around with these values as they are mesh dependent, and the idea of these values is that the vision cone starts a little behind the head, not exactly between the animal eyes. Let's test our code. This is where I realized that I made a mistake and replaced the selector node with a sequence node in the behavior tree. In our animal blueprint, let's add a capsule collision and parent it to the animal head bone. We need to resize it to cover the mouth of the animal. We will use it to detect the collision with the food. Right-click on the capsule in the Components viewer and, from the Add Event submenu, click on Add on Component Begin Overlap. This will add the event in our event graph. From the other actor pin, search for get class. From the return node, search for equal and select BP_food. Create a branch node and plug the result of the comparison. Create two new variables of type float, name them hunger and max hunger. Create one more variable of type boolean and name it as hungry. Make all the variables public. You can do that by clicking to open the eye at the right of the variable. Compile the blueprint in order to be able to set the default values to the variables. Set the hunger and max hunger values to 100, and leave the isHungry variable set to false. Right-click and search for Get Random Reachable Point and Radius. From the other actor pin, search for Get Actor Location. Connect the return value from the Get Actor Location node to the origin pin of the Get Random Reachable Point and Radius. Set the radius to 500. From the True branch, search for Spawn Actor from class and select BP_food. Right-click on Spawn Transform and select Split Struct Pin. Now, connect the Random Location pin to the Spawn Transform location. From the Exec node, search for Destroy Actor and connect the other actor pin to the target pin of the Destroy Actor node. You can use reroute nodes to make the blueprint more organized and readable. Drag the hunger value on top of the exec node. This will create a set variable node. Right-click and search for clamp float node. Drag the hunger variable a second time and create a get hunger node. You can drag it while holding Control key. This will create the get node. If you hold Alt while dragging, will create a set node for the variable. Add 10 to the hunger variable and connect it to the value pin of the clamp node. Connect the return value to the set hunger node. This will ensure that the hunger variable value won't be greater than the max value parameter. I will connect later the max hunger variable to the max pin of the clamp node. You can do that now though. Now we have a food respawn system that will spawn a new piece of food in a random location every time the fish eats a piece. Compile and save your blueprint. Now, let's create a drain hunger function. This will decrease the hunger by a small value every 0.1 seconds and set the isHungry variable to true when a threshold is reached. It will also set a Blackboard variable that we can use in our behavior tree. To create the function, click the plus sign next to functions in the left panel. Name it drain hunger. From the variables list, drag the hunger variable while holding Control. Next, search for the greater node. From the exec node, create a branch node and connect the result of our comparison. We want to execute this function only if the value of the hunger is greater than 0. Drag the hunger variable over the true branch. This will create a set variable node. From the list of variables, drag the hunger variable while holding Control and create a subtract node. Set the value to 0.1. This will be the value that will be subtracted from the hunger variable. Connect the result back to our set hunger node. Now, get the hunger value again. You can use the variable from the list or the return value of the set node. Create a less node and set the value to 30. From the set hunger node, create a new branch node and connect the result of the comparison. Drag the isHungry variable over the true branch and set it to true. From the false pin, create a new branch node. Now get the hunger variable again and create a greater node. Set the value to 80. We want the animal to feel hungry when the value is less than 30 and start looking for food and eating until the hunger value goes above 80. You can set these values as you see fit. Connect the result to the branch node. Drag the isHungry variable over the true branch again and set it to false. Let's add a text render to our fish so we can see the hunger value. Go to the Viewport tab. From the Add button, search for text render and add it to the blueprint. Position the text above our fish and set the color to something visible. I'll set it to red. Name the text render hunger val. Back in our drain hunger function, get the hunger val. From it, create a set text node. Drag the hunger variable over the value pin of the set text node. This will set the text value to our hunger value and will handle the conversion for us. Now connect the exec node from both set isHungry nodes and the false pin of our last branch node to the set text node. Back in our event graph, from the begin play node, create a timer by function name node. Set the function name to drain hunger. The interval to 0.1 seconds. This is how often you want the function to run. And set the looping value to true. This will make the function run every 0.1 seconds. Now we have a simple hunger system for our animal. Add a new variable of type timer handle and call it hunger timer. This will allow us to stop, start, or reset the timer in case we need to. Drag it over the return value of the set timer by function name node. This will create the set node and connect it. One last check that everything is in place. Connect the max hunger value to the clamp node if you didn't do it already. Back in our drain hunger function, let's set a Blackboard key to use with our behavior tree. Right-click on an empty space and search for Get Blackboard. From this, search for Set Value as Boolean. Connect the node to the Set Text Exec node. From the key name, search for Make Literal Name and set the value to as hungry. This will be the name of the variable that will create inside our Blackboard blueprint. Connect the is hungry variable to the bool value. Compile and save the blueprint. Now go to our behavior tree and select the Blackboard from the top right corner. Here create a new variable of type Boolean and name it as hungry. The name has to be the same as the one we set in the drain hunger function for it to work. Back in our behavior tree, delete the cooldown decorator we had on the investigate and eat sequence and add a new Blackboard decorator. Set the Blackboard key to the isHungry variable as we want this branch to be executed only if the food actor is set and the animal is hungry. Pay attention when setting decorators as they are executed from top to bottom, so the position is very important. You can see the execution index in the circle next to the decorator. This tells you the order in which everything is executed. From the main selector node, create a new selector node and, from this node, connect the investigate and eat node. We will create a new sequence that will execute when the animal is hungry and there is no food actor set. This will make the animal search for food when hungry without waiting. From the selector, create a new sequence node. Add a new Blackboard decorator. Set the Blackboard key to is hungry and key query to is set. Here I'm setting it to is not set, but it's wrong and I'll correct it later. We want this sequence to run when the animal is hungry, but the food actor is not set so he can search for food. Add the run EQS service also, as we need it to run in order to update the food actor variable. Set the query template to our EQS_site blueprint, and don't forget to set the Blackboard key to food actor. Here I forgot to set it, and I realized that a bit later after a long debug session. This sequence will have a BTT_roam task, a wait task set to 0.5 seconds as a buffer, and a move to task with the Blackboard key set to selected location. We also need to set a new Blackboard decorator to the sequence with the query key set to not set and the Blackboard value set to food actor so that the branch will execute if the food actor is not set and the isHungry value is true. Name the sequence search for food. I'm adding the isHungry Blackboard condition with key query is not set to the idle state selector also. In the end, it will be the only condition we need on this selector because if the fish is hungry, we want the search for food branch to execute. And here I'm changing the key query to is set for the isHungry condition and adding the food actor is not set condition. This is where I realized that the food actor is not set and correct the mistake by setting the Blackboard key to the food actor variable for the run EQS service from the search for food node. Let's test it again. We can observe the behavior tree executing as intended, and the drain hunger function operates correctly as the hunger value gradually decreases. Additionally, we notice that the isHungry variable is set to true when the fish's hunger value drops below our threshold of 30. The only issue we have is that the acceptable radius of the move to task is set too high and the fish doesn't touch the food. Let's fix that. In our behavior tree, select the move to task from the Eat if Hungry branch, and from the details panel, set the acceptable radius to something smaller. I'll set it to 5. Save all your files and test. We can see all the branches executing correctly and all our variables being set accordingly. We can see that the food gets eaten, and a new one appears in a random place after that. Concluding this video, we delved into the concept of decorators and their creation. Furthermore, we explored the setup and utilization of environment queries, along with leveraging the AI perception component. Your viewership is greatly appreciated, and I hope you found this content valuable. Kindly share your comments and suggestions in the comments section below. Thank you for watching, and don't forget to subscribe and hit the bell to make sure you won't miss our next episode.